Good morning all. I am Nini K.A., Assistant Professor, Department of Mechatronics Engineering, Jyoti Engineering College, Cheruthurthi. Today I am dealing with multiplexers, a part of combinational circuit from module 5. A multiplexer, or otherwise it is called as a data selector. It is a combinational circuit with more than one input line, one output line, and more than one selection lines. A multiplexer selects binary information present from one of the many input lines depending upon the logic status of the selection inputs and routes it to the output line. Normally, there are two n input lines and n selection lines whose bit combinations will determine which is selected. The block diagram of a multiplexer or MUX is shown here. You can see there are the data inputs and the output signal. Also, the control signals or select lines are present. A multiplexer is also called a data selector since it selects one of the many inputs and steers the binary information to the output line. According to the control signals or select lines, one of the many input lines are selected and it is given to the output. 2:1 multiplexer. Here there are two data input lines, one output line and one selection line. I0 and I1 are the input lines, S is the selection line and Y is the output. When S equal to 0, the upper AND gate that is corresponding to I0 that will be selected and will be enabled and has a path to the output. So I0 will be present at the output. When S equal to 1, the AND gate corresponding to I1 will get enabled and it will steer the input I1 to the output. The logic diagram and the truth table is shown here. From the truth table, when S equal to 0, I0 will be selected. When S equal to 1, I1 will be selected. Next is 4:1 multiplexer. Here there will be 4 input lines and 1 output line. Also there will be 2 select lines. According to the select lines, the input will be steered to the output. So here there are in 4:1 multiplexer, there are 2 select lines and the combination for the select lines will be 0, 0, 0, 1, 1, 0 and 1, 1. And according to the select line combination, the input will be obtained at the output side. The logic diagram is as shown. So when S1 and S0 is 0, the first AND gate corresponding to the input I0 will get enabled. So S1 is 0, S0 is 0. So here the NOT gate is connected to the first AND gate. Here the 1 will be obtained and here also S0 is 0 and it is imported, that is 1 will be reaching at the first AND gate. So both the inputs are 1 and the I0, according to the input I0, the AND gate will get enabled and it will reach the OR gate. When this is 0, 1, according to the combination S1 and S0, corresponding inputs will be selected and it will reach the OR gate and we get the output Y as the inputs. You can see the truth table. S1 and S0 combination. According to the S1 and S0 combination, what output is obtained at the output? For 0, 0, the output obtained is I0. For 0, 1, the output obtained is I1. 1, 0, I2. 1, 1, I3. This is the explanation for that. Consider the case when S1, S0 is equal to 1, 0. The AND gate associated with I2 has two of its inputs equal to 1 and the third input is connected to I2. The other 3 AND gates have at least one input equal to 0, which makes the output as 0. The OR output will allow the value of I2 providing the path from the selected input to the output. And we can see the data input is equal to I0 only if S1 is equal to 0 and S0 equal to 0. So for the combination of 0, 0, that is S1, S0 combination as 0, 0, we get y equal to I0, and for S1 S0 combination as 0 1 we get y equal to I1, and the expression for the same output we can have as y equal to I2 into S1 S0 complement for S1 equal to 1 and S0 equal to 0, and for y for S1 equal to 1 and S0 equal to 1, y equal to I3 S1 S0. The output can be expressed as y equal to the OR combination, because all these AND gate outputs are connected to an OR gate. We can have the expression for the final output as y equal to I0 S1 complement S0 complement plus I1 S1 complement S0 plus I2 S1 S0 complement and I3 S1 S0. The application includes signal routing and data communication. It is used for connecting two or more sources to guide to a single destination among computer units, and it is useful for constructing a common bus system. One of the properties of multiplexer is that Boolean functions can be implemented by this device. We can see the implementation of Boolean function using a mux or a multiplexer. Any Boolean or logic expression can be implemented by using a mux. A Boolean expression of n plus 1 variables can be implemented using a mux with 2n inputs. We can see one problem. Implement the following Boolean function using 4:1 mux, and the function is given by f of abc equal to sigma m of 1356. The variables here include abc, that is n equal to 3, and the select lines will be n minus 1, which is equal to 2. We take it as S1 and S0, and we use a 4:1 multiplexer for this. The inputs are D0, D1, D2 and D3. The implementation table includes the following. Apply the variables a and b to the select lines. And the procedure for implementing the function are: list the input of the multiplexer and all the minterms into rows are to be included. The first half of the minterms is associated with a complement and the second half is associated with a. And the given function is implemented by circling the minterms of the function and applying the following rules to find the values for the inputs of the multiplexer. The first rule is, if both the minterms in the column are not circled, then apply 0 to the corresponding input. If both the minterms in the column are circled, then apply a 1. If the bottom minterm is circled and the top is not circled, then apply C. If the top minterm is circled and the bottom is not circled, then apply C complement to the input. We will see that. We can see the minterms provided in the question was 1, 3, 5 and 6. So first we have to write the inputs D0, D1, D2 and D3. Then we are writing the complemented first, that is C complement and C, and we are writing the minterms in order wise 0, 1, 2, 3, 4, 5, 6 and 7, and we have to circle the minterms present in the question, that is 1, 3, 5 and 6. And here, looking at the first input, that is D0, the column, both are not circled, so we can apply a 0. If both are circled, the rule is 1 is to be given as the input. Then the lower one is circled and the top one is not circled, so the one circled, that is to be given as the input. And here 3 is circled, so C complement is to be given as the input to D3. This is the implementation by using a multiplexer. We can see the D0 is 0 here, so we can ground D0. D1 is 1, we can give a high signal or 1 signal. Then D2 is C and D3 is C complement. So to D2 we can apply C, and to the D3 we can apply C complement. This is how minterm, or we can implement Boolean function by multiplexers. Hope you understood. Thank you.